This presentation is delivered by the Stanford Center for Professional Development.
Well, good afternoon, everybody, and welcome to the Thursday, December 6, 2012 session in our series on green technologies in transportation. And today is the ultimate session in this series. I'm Richard Dasher. I direct the U.S. Asia Technology Management Center, and we produce the series. We also want to recognize additional financial assistance from the Alan Miner Foundation and Sunbridge Partners. We've got some refreshments back in the back today, and we hope you'll join us in meeting with our speaker and meeting with each other. That's some of the best parts of these sessions, and thanks to Alan for the support that allows us to do that. For students who are registered for credit, the scheduled exam time for this course, if we had an exam, would be Thursday, December 13 from 12:15 to 3:15 in the afternoon. This means that let's make Thursday, December 13 the deadline for all of the materials that you need to finish up in order to get credit for the course. That includes any kind of makeup papers that you might be writing, as well as your summaries for today's session. So make sure you get everything to me by email by December 13. I'm very happy that we can welcome Mr. Lou Thompson to be with us today and talk about what the U.S. should learn from the Asian high-speed rail experience. Lou is probably uniquely qualified to give this presentation. He has a Bachelor of Science from MIT and an MBA from Harvard, and then he worked around at some companies and had several jobs with what used to be called the Federal Railway Administration. And this was back in the late 1970s until the mid-1980s, including being the director of the Northeast Corridor Improvement Project during that time. And from 1986 until 2003, he was Railways Advisor to the World Bank. And so we were talking about comparing business trips before the session started today. From 2003, Lou has been a principal of a consulting firm, Thompson, Galenson and Associates. He's also currently a member of the board of directors of the Railway Research Foundation, and he's a member of the peer review panel for the California HighSpeed Rail Authority. So we're very delighted that Lou can come and talk to us about railways and what we should learn. Thank you for coming.
Thank you, Richard. A ground rule, it doesn't bother me if you have a question to ask it whenever we get to it. One of the things I dislike about lectures is having to wait until the end and then I've forgotten my question, or if I pose it, it doesn't make any sense in the final context of the lecture. So feel free if you want, this is not that large a group, feel free if you want to ask a question. I want to do several things. First, the topic that I was asked to talk about is Asian high-speed experience, and I'm going to talk about Asia as if it were China, Taiwan, Japan, Korea, and India. That's kind of an incomplete definition, many people would think. But these do represent the major railway countries in Asia, and in fact, especially China, Japan, and India, the major railway companies in the world. So it's a worthwhile sample to use in comparing with the United States. I want to talk partly about comparative roles and scales of the systems. The problem is that each of us has in his mind a view of something called a railway. Many of you had a children's book and there was a steam locomotive or Thomas the Tank Engine, and you still kind of have that image in your head. Well, railways are very different. They're not the same even within the context of technology or services. So first I want to set the scene for you of why these railways are different and why the lessons that you learn, the technology they use, the way in which they approach problems can be quite different. Then I'd like to talk a little bit about structure and finance of the comparative structure and finance of the system. Because structure and finance, and then indeed the institutions and the policy, are what make technology either work or not work. Technology doesn't exist all by itself. It doesn't exist in isolation. And some kinds of technologies work in one set of structures or finance, and they don't work in others. So it's important to know what the context is in which these issues are being addressed. First, let's look at passengers carried. And as you can see, the U.S., by the way, looks like 0. It isn't, but it's kind of close. I've shown high-speed rail in green and then all passengers in the orange color. The U.S. doesn't even show. I mean, it's there. I put the numbers, but on this scale, you can't even find it. The U.S. is not a railway passenger country. By comparison, Japan and India are enormous numbers of passengers. Enormous numbers of passengers. China is lower, Korea is lower, Taiwan is lower. High-speed rail, compared with the total conventional passenger system, the high-speed rail in numbers of passengers is just not that large. In most of these countries, what the railway is really doing, where you see the high number of passengers, is it's hauling suburban passengers or short-haul passengers. And high-speed rail is only a part, and in many cases, a minority part of even their passenger business. Yes, you.
What unit of time is this per year?
This happens to be 2010, the year 2010.
Well, I got you.
Sure.
I'm having trouble with zeros. That's 800 million passenger
No,
trips?
it's 8 billion.
8 billion passenger
Yes,
trips.
8 billion.
Okay.
That's
Okay.
8 billion passenger trips in Japan. That's, what, 40 times the population. Not surprising. No, suburban it includes conventional railways, not the metro, conventional railways and the high-speed railways. So the traffic of the 6 JRs is what this includes. Passenger kilometers is another measure of the same thing. This is the product of the number of passengers times the length of their trip. This is the more conventional measure in transportation of output. And you get somewhat the same picture, although things shift a little bit. Again, the U.S. is negligible. We do have some high-speed rail. It's called the Acela that Amtrak operates between New York and Washington and Boston. It does reach 150 miles an hour for about 20 miles of the 450-mile trip. So it's sort of high-speed rail, but it's tiny. China reports no statistics, so I just can't tell you about their high-speed rail system. What you get is reports of accidents occasionally or their construction program, but I know nothing about the numbers of passengers or passenger kilometers. India, again, is enormous in terms of passenger kilometers, much larger than the other countries, but no high-speed rail. No high-speed rail in India. And then you can see how Korea and Taiwan fit into this comparison. But even by comparison with Korea and Taiwan, the U.S. rail passenger service is tiny, really small. And that we'll see why that's important a little bit later. To put this in a different context, now I turn it around and tell you about the freight service of the railway. Which are the railways that really matter in freight service? And now the U.S. matters a lot. The U.S. is a freight system. It really isn't a passenger system. We have a few passenger trains running around, but the U.S. is a freight system. China is an enormous freight system as well as an enormous passenger system. China is the largest railway in the world measured by the total traffic that the railway carries, and it has been the fastest growing for many years. India is significant, Taiwan, Korea, Japan. Japan doesn't really carry very much freight, kind of residual from many earlier years. This puts it a different way. What I've shown here is the percentage of the total traffic of the railway that is passenger service. So it's passenger kilometers divided by the sum of passenger kilometers and ton kilometers. It's a rough measure, but it's a good indication for you of, is this a freight railroad or a passenger railroad for the most part? 0.3% in the United States is passenger service. 0.3%. China is 24% passenger service. Characteristic of European EU countries is 30 to 60%, something like that, in that range. Taiwan is 95% passenger, Japan is 92% passenger. So they're very different systems, and the management is trying to do different things. And the mentality required, the ideas, the objectives of a passenger railway, and especially a high-speed railway passenger railway, are utterly different than a freight railway. So when we think about what lessons are there and how would they be transferred or learned, you have to keep in mind that some lessons aren't relevant. Maybe it'd be nice to learn them, but we can't do anything about them.
Question.
Sure.
Why did the systems develop in such a different way? In the U.S., passenger railway traffic really declined with the advent of the airplanes in the 60s, is kind of my sense.
Much more with the advent of the interstate highway system. Both of those things killed rail passenger service in the United States. But the other thing that killed rail passenger service in the United States was it's not profitable.
But there's also something...
Our system has always been operated by private companies who operate things they can make money with, and they don't operate things they can't make money with. And their mentality was driven by a perfectly valid profit motive in our system. But that was Japanese National Railways prior to, well, I'm getting ahead of myself, but to answer your question.
Yeah.
Prior to its privatization in 1987, Japanese National Railways was losing $15 billion a year. $15 billion a year, and they had a debt of something like $250 billion.
Wow.
So when you're passenger-oriented, when there's a public service objective in mind, you have one way of approaching a problem, and you recognize one set of measures of capital efficiency. You invest differently because you're measuring your rate of return differently, if at all. So the approach to all of these things, investment, management, traffic, marketing, they're all dependent on these variables of what kind of service am I providing and what kind of market am I serving. And it radically affects the way they think. Let's talk a little bit about structure and finance of these systems because it is quite different. The U.S. system is vertically integrated. By vertically integrated, I mean that the operator owns the tracks. They're integrated together, and one company controls the use of both the services and the tracks. We recognize Amtrak as being a separated operator that runs throughout the system and pays for the use of the track, but the freight is integrated, vertically integrated with the track. We have 9 so-called Class 1 freight railroads. These are railroads with revenue more than about $370 million a year. We have something like 500 short line railroads or one kind or the other, remnants of old railroads, ma and pop operations, whatever. And then the freight railroads are private, but Amtrak is publicly owned and it is publicly financed. That's the way we do this. In Japan, the high-speed rail is vertically integrated with the track, has been. The conventional passenger systems, these are the narrow gauge, so-called narrow gauge system, Cape gauge system, is also vertically integrated, but the freight railway is like Amtrak. The freight railway operates on the entire system and pays trackage fees for it. There's 6 major passenger railways. There are a lot of private railways in Japan that don't figure in this calculation. Something like 30% of the kilometers of track in Japan have never been part of JNR or the major Japanese railway companies. There's only one freight company. The old JNR was publicly owned, and it carried all kinds of public burdens. For example, after World War II, they were required to hire returning veterans, simply as a way of giving them a job. So the objectives of the company were not only private or even passenger service, they had public objectives. 3 of the new JRs are private. They were sold, the shares were sold. I wish I had bought them when during their IPO. Some of them have done very well. They're profitable, they're stable, they do very well as private companies. The state, 3 of them are still public, and they're subsidized by an interesting device. A trust fund was established for them, and the earnings of the trust fund are used to subsidize the operation of the 3 smaller JRs, so that they are not subsidized every year by appropriation. They have a stable income to depend on. The freight service, the government has yet to figure out what to do with it. It's very difficult to operate, it's not profitable, but at the same time, they're not quite clear what they should do with it. Financing is a mix of public money, private money mostly for the private companies, but public money mixed with private money for investment in, for example, new lines that the government wants to build, and there is a balance of public and private profits to be earned. China's monolithic, one railway, one company, one size fits all, and it's fully public, although the MOR, the Ministry of Railways of China, which is the official name of this, and note that it's a ministry, not even a state-owned enterprise, it's a ministry. It has done some private borrowing. People assume that the bonds of the railway are backed by the railway and by the government. We'll see.
Okay.
Yeah.
Jump again.
Yep, sure.
So there are some private bonds. Are taxes going directly to help subsidize operations?
No, no.
Okay.
The railway is, quote, profitable.
Okay.
It earns revenues in excess of its operating costs, maybe significantly in excess of its operating costs.
Which is kind of amazing considering the fares are very cheap. You know.
Wait a minute. China, the fares are not so low, and compared to India, for example, where the fares are derisory low. In China, the passenger fares, on average, are roughly like the freight fares. In India, they're about 1/3 the freight fares, and in the United States, they're 15 times the freight fares. So if you want a sense of the way in which they earn or don't earn money. But Korea, it's monolithic. They have separated high-speed rail tracks, as they do in China. There's only one company, Korean Railways, and it's wholly public. Taiwan is very interesting because the high-speed rail system in Taiwan was built as a private concession. The government awarded a concession to a private consortium, and they promised they would build a system, they would operate it, and they would not ask for any government money. Didn't work out that way. But they got well into it, and then for a lot of reasons, some of which were not their fault, political interference. They ran out of money, and the government has had to buy about 15% to 20% of the company. But that's all. They have 2 companies, the THSR, Taiwan High-Speed Rail, and then the Taiwan Railways. And it's mostly private for high-speed rail, public for the conventional services. And then, by comparison, India is kind of the most monolithic, the most public, the least exposed to any kind of private finance or private structure. Indian Railways is immense, immovable. Their symbol is the elephant, and they're right. Institutions and policies for high-speed rail in these countries differ also. We well, I don't know what this thing did to my typography. It's interesting. Anyway.
This is what happens when you take a PC and PowerPoint and put it onto a Mac.
Aha! Okay, well, anyway, you can see what I was trying to say here. Okay. Amtrak is our only intercity passenger company. In fact, it has a monopoly on intercity passenger services. That was part of the deal under which it was created. There are some new state-level agencies for high-speed rail, like California, that have been created. They have unclear mandates. Their financing is not stable or sufficient. They have little or no expertise to really get the job done. By comparison with JNR, which could design everything, construct everything, manage everything, they had a clear mandate. I say here, JRs they're private institutions, they have clear mandates, they have deep experience, they know exactly what they're doing. Here in the US, government support for high-speed rail is about that thick. It's this broad, but about that thick. That is, the Obama administration has said it likes high-speed rail. It provided some money in the American Rebuilding and Rehabilitation Act, but there is no real government program in existence. There's a policy that would be nice to have one, but in this budget environment, it has to compete with every other thing that wants money. Unlike the Interstate Highway Program in the US that had a stated amount of gasoline tax, they knew what the money was, it was dependable, they could plan, they could manage around that. And the interstate highway system, which took 35 or 40 years to get built, got built. It was planned and built, and it may be one of the most successful large infrastructure projects ever done anywhere. Very little corruption, very little diversion of money, except that there was a problem. We don't need to discuss that. But basically, it started as an interstate program. It ended up being a series of commuter highways. That's where the money is on the interstate highway program. It's on the commuter highways and not on the interstate part of the highway. Okay, MOR has a very clear mandate. They have deep experience. They have real implementation capability. In fact, maybe too much. When in China, it's interesting to work in China because there are fierce debates about what's going to be done, but once that has been settled, it is done. Finished. Amazingly fast, possibly too fast. There's not much public information available about who's doing what. And some of the high-speed rail in China was actually built not for high-speed rail, but in order to get traffic off the freight railway. The freight railway in China the railway in China in general has the densest traffic pattern of any railway in the world. It's approximately 3 times the average of the United States. So passenger rail and freight railway don't coexist on the same tracks very well. And high-speed rail on freight tracks is impossible for a lot of reasons. So when the Chinese began to want to speed up their passenger trains, they had to get them off the freight tracks in order to improve the freight capacity. Korean Railways has a clear mandate and full expertise. The program pace has been deliberate. They've not been in a hurry. And they've also operated pieces of the system where the high-speed train runs fast when it can and then slow when it has to. So they've been able to link it with the system and organically grow. The government support has been clear and pretty stable. Taiwan, as I said, was intended to be private, but it didn't work out that way. The government was too ambitious, I think, about this concessioning, and they may not have reached a stable solution even now. They assumed away a lot of, this is another problem you need to think about. They didn't know how to do what they tried to do. Concessioning a high-speed railway de novo is a very, very complicated problem. It had not been done in Taiwan, hasn't been done in the United States either. But they took it on, and they're gradually getting there, but they haven't gotten it there yet. Indian Railways, as I said, is slow and bureaucratic. Technically, they can build and operate railroads, but they have no experience with high-speed rail. They do have some plans for high-speed rail in India, but I think their priority right now is more on the freight side, building a dedicated freight railway, than and that's what they call the Golden Quadrilateral, rather than on building high-speed rail. So, what do we learn from all of this? Well, some broad lessons. First of all, as I've said, the technology is a lot of fun. I love it. I really enjoy the pictures of the high-speed trains and Mount Fuji in the background or whatever. That's a lot of fun. But that really isn't the problem as far as I'm concerned. There are plenty of countries that know how to do the technology. France, Japan, excellent. China, probably, others. The technology exists. It does not exist to run 220 miles an hour. That has been done in testing conditions, but day in, day out in revenue service, 220 miles an hour is stretching the state of the art by about 30 miles an hour. And as you know, energy, wear, all of those things are exponential on high-speed railways. So, we need a much clearer understanding of what's the public role here and what's the private role here. I will assert that no high-speed railway has ever been built purely with private money. There are some that are owned now privately, the Japanese national railways, those, they weren't built with private money. And the process of privatizing the company, it still isn't clear how much debt was transferred, what equity ended up here, and therefore whether these, quote, profitable high-speed rail companies are really earning high rates of return. That's the definition of the investment. We in the U.S. have almost no experience with private operation of passenger trains. Strange, but it's true. I used to say we were the last bastion of railroad socialism. We always have operated our commuter trains and our passenger trains with a public entity. And we don't have any experience with private sector companies operating these for profit. We have very little or no experience with PPPs in passenger rail service. We do have some experience with what I would call a management contract. Caltrain here is a management contract, but it calls for very little investment on the part of the operator, very little marketing expertise, very little of the thing you would expect to see to make a private sector kind of venture successful. It's just, I'm hiring you to run my railway in the following way. What we also don't do in the United States, and we could learn from Japan, especially Japan, is how to measure public benefits as opposed to private benefits, and then how to have the public sector pay for its benefits and the private sector pay for its through revenues and operating costs. We simply still don't do that well in the United States. We're okay if the private sector can do it fully. We're okay if the public if the public sector has to do it. At least we know how to organize these and manage them. What we don't know how to do is manage those that have a leg in both pots. That we don't know how to do, and we could certainly learn. Another lesson from Japan and China, the others, is that the critical role of being able to do stable planning and financing environment. What we do in the U.S. right now for high-speed rail is we have a 50-year project, but 1 year financing. And next year, maybe we'll have it, maybe we won't. Or maybe there'll be an argument and the Republicans will do this and the Democrats will do this. And we will have to forego that year's funding. You can't do this kind of project that way. And the Asian countries have been able to plan stably and then fund stably. And that is, we did it on the Interstate Highway Program, yes. So we know how to do it. But we need to apply that lesson to high-speed rail if we really want high-speed rail. As I said about managerial capability, it doesn't exist in the United States. It just doesn't exist. And it takes years to build this kind of capability. It takes a long, long time and a lot of experience and a lot of mistakes. Overall, I think my experience in Japan was that plus or minus, they knew exactly what they were doing. They knew what the demand was going to be. They knew what the cost was going to be. They knew how to manage it. And they knew how to integrate what they were doing into the national and the local level transportation planning. So they didn't build a high-speed railway station and then suddenly find out there was no mass transport to take the people to or from the station. They had a picture of the entire system in mind. In the US, the Federal Railroad Administration, which is handling the high-speed rail money, doesn't talk to the Federal Transportation Administration, which handles the local transportation money. It's not that they don't like each other. It's just that they don't talk because they're different agencies and there's no requirement that they talk to each other. So you can easily have situations here in which, in California may be an example, in which the high-speed rail will arrive in a city only to find out that there's no bus service to serve the station, or no trolleys, or no transit, or no anything else other than possibly a gigantic parking lot. And that's a lesson that the Asians, all of them, have learned, and all of them employ, and one that we really should employ here. So that's kind of my distillation of what we should learn. There are probably other lessons, but those are the ones I think are the most important.
So that's it. Thank you very much for your comments. So this is great because this does leave a lot of time for discussion. Good. I want to ask you, with regard to the kind of greening of railways, what are some of the trends that you see that are happening either here or in Asia to make them more environmentally friendly? Things that just come to the top of your head.
Well, two things really. One of them is that if you look at the energy consumption for the high-speed railways in Japan, at the same speed it's been going like that for years. So at the same speed they've been able to decrease the energy consumption and therefore increase the energy efficiency of the trains. But more than that, I think it's a mistake to look at high-speed rail in terms of energy or CO2 or emissions, because that isn't really where the benefits are. It's there, but that isn't really where the benefits are. The benefits, I think, in the long run have much more to do with planning of the use of land and the way in which it is managed, so that in California we could have people grouped in our cities and not scattered all out through environmentally sensitive areas or places where people really shouldn't be living. It permits you to organize the way the society operates much more efficiently and effectively than we get with just a highway model, as we know. But it goes back to the question of how do you define the public benefits? What do you include within your computation of a public benefit? How much is it worth to be able to organize people to live in a particular way efficiently in a city rather than scattered, a la Los Angeles? What is that really worth to us? And we're not good at it. And I'm not sure that we're good at assigning a value to it either.
So all the more the interstate highway system is an amazing kind of rare example in the U.S. of a long-term, huge-scale project that worked.
But even there, the interstate highway system is very interesting because it's an example of a program that started out right and then it kind of got away from us. Because if you look at the original planning documents for interstate highway system, it has wonderful lines, and then there's a circle around the city. The original plans didn't have these beltways or things. It had beltways, but it didn't have the urban links and the things that went right into the middle of the city and just bulldozed away neighborhoods and other things because people wanted to be able to drive to work. As the program gathered momentum and money, the objective shifted, or the way in which the money was spent shifted. And that which was going to be an interstate program, mostly for long-haul transportation, measured by money and measured by passengers, not by freight, but by passengers, became much more of an urban highway system with interurban links than an interurban system with urban
Okay,
connections.
so I've got one more question, then I'll open up the floor. You and I got to meet each other at the beginning of October in this program where a lot of talk was made of maglev,
Yes.
the plans for JR Central to develop this, maglev track all the way from Tokyo to Nagoya by way of Nagano. What's next? Do you see major new technologies like that transforming rail traffic yet again?
Well, back up. Rail hauls freight,
Okay,
immense amounts of freight. The linkage between ton kilometers and GDP is very clear and it's very well established. Ton kilometers come
Yeah,
first
right.
in a sense, okay? The linkage between GDP and passenger kilometers is much less clear. It's certainly, you can argue that GDP drives passenger kilometers, but it's much harder to argue the other way around, that we didn't have all those passenger kilometers, we wouldn't have that GDP. So it's a different question about what do people use passenger transport for, and why would they want to ride a railway, why would they want to ride a high-speed railway, and why would they want to ride a super high-speed railway? If you look at the service capability, I should have brought this chart, but I didn't. If you look at the service capabilities in terms of trip time, total trip time, you find that the automobile dominates for 50 miles no matter what you do, as long as there's no congestion. Once there's congestion, then mass transit does very well for short trips. Between 50 and, let's say, 200 miles, conventional rail is just as fast as high-speed rail because the speed doesn't really do much for you. Between, let's say, 150 miles and 500 miles, high-speed rail begins to, that's its competitive zone, its sweet spot, because it's faster than low-speed rail, but it's still faster than the airplane, which, though it cruises faster, can't make up for the delays in the airport and the takeoff and everything. By the way, one of the main competitive factors in rail versus air for short-haul trips is security at the airport. If security at the airport were ever fixed, air travel would suddenly become a lot more competitive for shorter haul trips than it is now. But at any rate, beyond 500 miles, there's no calculation you can make about high-speed rail that says high-speed rail is faster than the airplane. It just isn't. But if you have an enormous volume of people, Tokyo to Osaka, for example, where the volume to us is almost unimaginable, then investments in these extremely high-speed, highly efficient, high-capacity systems begin to make sense. But I am sure that JR Central is not thinking about Tokyo to 50 miles out for the maglev. That's going to be really long haul, very high speed. Now, where would you go from here? Well, there's always been discussion of short takeoff and landing aircraft on the one hand, and there's been discussion of things like high-speed trains in evacuated tubes. That's been discussed, and in fact, people were actually transported by pneumatic tubes before the turn of the century. Have you ever seen these have you seen the mail systems or the bill delivery? Well, there were actual people movers that, when you ended up at the other end of the state, hopefully in one piece. But, the technology is there. The question is it a solution in search of a problem? What problem is it trying to solve? And it gets harder and harder to make the case against airline travel when the distance gets beyond, say, 400 or 500 miles.
Okay, so the U.S. would be relevant for things like the Northeast Corridor, the North to South California
side. It might be relevant for Washington to Boston.
Yeah. Okay.
But it's not really relevant for Washington to Philadelphia.
Okay. Okay.
But another difference between the U.S. and certainly Japan is that our distances here are so much larger. That's not true of China, but certainly of U.S. and Japan, the distances that we travel routinely are much further than they do in Japan.
Go ahead. I saw your hand first.
Simple question. Okay, gauge is the same in all those countries for the rails for both high speed.
No. Well,
And are the cars interchangeable for both high speed and regular?
okay, that's a good question. And the answer is no, or sometimes, maybe better. The Japanese system was 3 feet 6 inches gauge. The whole system was 3 foot 6 inches. They decided that they could not run high-speed trains on narrow gauge track, that there was not enough inherent stability in the track to do it. So when they built the Shinkansen, the new lines, they're so-called standard gauge, 4 feet 8.5 inches. So that the Japanese Shinkansen cannot travel on the narrow gauge tracks and vice versa. There's some very specialized gauge changing stuff, but it's not very important. So if you want to go somewhere on the Shinkansen and then somewhere on the narrow gauge system, you have to change at a station. It works, but the genius of the TGV in France was that they realized that you could travel in a high-speed train on a low-speed track. So they built the high-speed segments outside the cities, and then into the cities is the existing conventional track. It's all standard gauge. And then extensions, like say Lyon to Geneva, those are on the regular track. Those are not done on the high-speed track. So that you can take advantage of the high-speed links in the system, but you can also operate off the system as well without having to get off the train and change tracks. China's all standard gauge, Taiwan's all standard gauge, Korea's all standard gauge, Japan is a mixture, India is broad gauge, 5 feet 6 inches. No one's ever built a high-speed train on that. We assume they could. The U.S. is all standard gauge.
Thank you.
Lou, I've had the pleasure of riding high-speed rail in at least 2 countries, maybe as much as 4. And so the benefits, I think, are very obvious. In reference to your last slide over here, what the U.S. can learn, along with the parallel with healthcare, is there a willingness in the U.S. to look at successful projects in other countries? Because my sense is that's a hurdle right there in government at times to overcome.
I'm not sure I understand the question.
Well, if you see a successful solution, is there the willingness to sort of look at that as the first blueprint in the U.S.?
Let me ask the question in a different
No,
way.
I think
Okay,
I understand
okay.
that. Is there some reason why we don't buy somebody else's technology and just use it? Why do we invent it ourselves?
Well, maybe not that far,
Yeah.
but just benefit from the knowledge, the pre-existing knowledge.
Generally speaking, the proposers for high-speed systems in the United States have been supported by either the French or the Japanese, and sometimes the Germans. So it's in fact, we've not in the U.S. attempted to invent our own high-speed technology. We did in the 70s. We were trying to invent our, in fact, maglev, some of the first maglev stuff was done in the United States. But very quickly realized that when the Japanese have 8 billion passengers and we have 32 million or 23 million, why in the world would we want to invent technology that they're much better at than we are? So I think the U.S. has actually been fairly good at realizing, aerospace companies of the country notwithstanding, at realizing that we just don't need to do this ourselves. We can buy it from somebody else.
Let me ask a follow-up on that. So from what I know, which is very little, California essentially put out the high-speed rail project sort of to a bid to these different technologies, right? To the different countries?
No, not really. In fact, one of our concerns has been that the High-Speed Rail Authority has tried to stay technology neutral as long as they can. Now, the argument for that, of course, is that as long as you're technology neutral, you maintain competition. As soon as you say we're going to use Japanese technology, then the number of bidders available for all kinds of things goes poof, or French technology, same thing happens. That's fine, but at some point, a decision on who's going to operate the system has to be made. That operator is almost certainly going to be a concessionaire from Japan or from France or from Germany or wherever, and they're going to be very uncomfortable if they're Japanese driving French trains. They're just, and using French technology, and et cetera. They don't know how to use it, they're not familiar with it. So there's going to be a point at which choices have to be made.
And then they're going to have to learn the U.S. market.
They certainly are. The problem is that the traditional, especially Japanese, approach to the U.S. market has been fire and forget. We'll build trains there and we'll sell them, but we don't want to have anything to do with operating the system. So we're happy to sell you rolling stock, and then you take it from there. The emphasis in most concessions is we want you to operate the system for us. Bring the rolling stock, do the marketing, bring the ticketing, bring the other
and make
things.
it work.
And hire U.S. employees. It would be silly to bring Japanese to drive trains in the U.S. But bring your expertise and run the system for us.
No, this is a really
And
interesting.
that's a different issue and a different set of problems.
Well, it's a really interesting thing because railways are in some way a service business, right? I mean, they are a service business.
Well, I like the emphasis on the word business. I mean, what's the point of a high-speed railway which is competing with airlines? Why wouldn't you realize that it's a business? The airlines certainly do. And the airlines' marketing and service patterns and the way in which they operate is intensely competitive. And the way you survive is understanding the business, not how do I run trains, but what's the business of hauling people. And generally speaking, public authorities don't do that very well. You need a concessioned operator with operating, marketing, commercial expertise to do it.
I'm asking too many questions. I saw a hand over here that I wanted to. Okay, then I missed it. Jim, was it you? Okay.
Did I understand you to say that 600 miles is not a really efficient competition with the airlines, or?
No, at 600 miles, the airlines always prevail on trip time, unless there's some unusual circumstances. 500 or so is the outer end of the possibility of a high-speed train competing with air. Much beyond that, the air is always going to be.
Now, of course, if you had a 600...
Los Angeles, I would much rather drive because I can get there faster than flying. By the time I drive to the airport, find parking, then I get to Los Angeles and I have to take a taxi in traffic. I mean, I might as well just drive.
You make a really important point,
Yeah.
which came up earlier, and that is don't think of high-speed rail in terms of numbers of people as competing with airlines. It's actually competing with the highway. There are only 7 to 8 million people who fly a year from all of the San Francisco airports to and from all of the Los Angeles airports. That's all. That's it. And so if you got 100% of the market, there's still something like 1/4 of the projected demand that they have right now. Amtrak, the way it operates right now, has nearly 100%, well, has 100% of the airline market from Washington to Philadelphia, Baltimore to Philadelphia, Baltimore to New York, and it has almost all of the airline market from Washington to New York already. So, that's 150 miles an hour for 20 miles and an average speed of 80 miles an hour. So what would a high-speed train accomplish under those circumstances? Well, it's not going to get any more airline passengers. Maybe it'll get people out of the car, and maybe it will generate induced demand, but it's not going to compete that well with airlines.
It's sensible to run a high-speed rail from the outskirts of LA to the San Francisco area, and then come down the Caltrain tracks at the regular speed, same train.
That's exactly what they're proposing to do now.
And why is there all this fighting about the tracks?
The original view of High-Speed Rail Authority was that they were going to show up in San Jose with the bulldozers and they were going right through the peninsula, 4 tracks, elevated right straight to San Francisco. There is no way they were going to do that. And the French didn't even try to do that in their system. What they did was they operate in a blended way, a combined way, so the high-speed trains come in and they mingle with the local trains. It reduces capacity, it reduces speed somewhat, but it reduces environmental opposition and it reduces capital cost immensely. So that's the trade-off that's been made. Yes, it makes eminent sense. But there's another thing to think about, and that is that the San Francisco market may actually be Caltrain to San Jose changing to high-speed rail rather than, Trans-Bay Terminal to LA. There may be much more people than we even realize now who will take Caltrain, a good Caltrain. And especially if BART makes the final connection to San Jose Station, then the real service may not be Trans-Bay Terminal to LA, it may be collected on BART and Caltrain to San Jose. After that, you can go whatever speed you want to go.
Yeah, absolutely.
In Japan, what kinds of changes have they made to achieve a continuous improvement in efficiency that you talked about?
Oh my goodness, all kinds of things. Design of the pantograph so that it's much more aerodynamic, building barriers around it so that it's more aerodynamic. If you look at the initial bullet trains, they have a kind of a blunt nose. If you look at the ones now, it's stretched out for 20 meters of very narrow, very thin nose, all kinds of aerodynamics. Interestingly enough, they did that almost as much for noise as they did for energy, because they had immense problems with high noise levels. And noise comes from wind resistance, among other things, and from the sound of the pantograph. And so they were able to use the technology for a lot of reasons, both of those in that case.
I thought your comments on integration with the other transportation infrastructure was really interesting. And when I went to a presentation here for the potential design of the Palo Alto high-speed rail station, they were kind of saying, now maybe you can help us figure out where we're going to put the garage for thousands of cars. I mean, I have a feeling we still don't get it, do we?
Well, but my remark is that we don't get it anyhow. We have Caltrain now. And what are we doing about providing good, now I'm speaking as a resident of this area. What are we doing about providing good access to our existing mass transit stations? Not a hell of a lot. If we did, Caltrain would look very different, and the systems might look very different. Caltrain is unique in that it's one of the very few mass transit systems I know of that has an almost balanced traffic north-south. That is, there are almost as many people going south in the morning as there are going north, and vice versa in the evening. So it's not, like it is in New York. It makes a much more economic system, and we're not taking advantage of it. Instead, we're arguing every year about funding Caltrain, and they're fighting this battle time after time. The management of Caltrain spends as much time playing local politics and trying to get money as they do planning and running the system. It is, they say, a hell of a way to run a railroad.
That's all your hand.
Yeah, so I was wondering what percent of freight is carried by air in the U.S. versus rail?
Very low, very low, very low. In percentage of ton kilometer, I bet you that if you look at the value, you get quite a different answer. I know that, let me extrapolate a little bit. Railways carry about 40% of the ton miles. Trucks carry, say, 30% of the ton miles. Maybe, yeah, that's about right, and then barges and pipelines, et cetera. But trucks earn 90% of the revenue, and railways earn 10% of the revenue. Another way to put that is that, this is a trick question. What would you say, measured by value of cargo, what would you say is the largest port in the United States?
Long Beach?
JFK.
Oh.
Port. JFK, the port of JFK, the air terminal, the international cargo terminal at JFK handles more cargo value than any other port in the United States. And of the top 10 ports, 3 of them are airports.
But Lou,
Measured by value.
I do want to step
Not
in
by
and
tons.
say there's really not any alternative to railways for moving very heavy raw materials like rock and, I grew up in not too far away from a phosphate mine. So,
Did I, by the way.
long trains.
Where did you grow up?
South Georgia.
Oh, goodness, I grew up in Central Florida, right in the middle of the
Okay, well, I was on the north side
Yeah,
of it, you were on
okay.
the south side.
I grew up south of you.
But, you see these 2-mile long trains where it's carload after carload of raw material. You cannot do that even by truck.
Each of the transport modes has its own sort of market. What railways in the U.S. do is, or railways around the world in the freight side, is very high volumes, mostly lower value cargo, but
Yeah.
not always. A unit train, and operating in what are called unit trains, that is, the train is buckled together at the beginning and it never is unbuckled until it gets to the end. One whole unit train. Sometimes 10,000 tons, sometimes 15,000 tons of coal in one train. Another kind of unit train is double stack containers.
Yeah.
That starts out at the port of LA Long Beach and it ends up in Chicago or even further east. And it's a whole 100-car train, double stack containers. Who knows what's in there? But it can be done because it starts here and it ends here and it never stops. Most theft on railways occurs in yards. If you ever stop the train, people will steal things from it. But if you keep it moving, then there's no theft. And if you keep it moving, then although railways can't really compete with trucks on speed, they can come close enough. But what the shipper wants is not just speed, but reliability. The problem that railways have had is not just speed, but reliability. Yeah, we'll pick it up sort of today or tomorrow, and we'll get it there whenever we feel like it. Trust us. And you can do that with coal or limestone, but you can't do that with television sets. And so the developing of the high-quality market for railways in the U.S. has been either containers or a very interesting innovation. The largest trucking company in the United States, J.B. Hunt, actually moves most of the cargo on the railway. They rent a train, an empty train from A to B. They market all of the containers. Railroad has no idea what's on that train. They just bring an empty train in, they load it up and they haul it over here and they pick it up over here. And that railroad is the wholesaler of transportation capacity. They have no idea what's in the train. And they did that for a reason that you wouldn't expect. The reason they did that is because they couldn't hire drivers anymore. Trucking companies had a 300% turnover in their drivers because it's a miserable way to make a living. You're gone all the time, you're driving all the time, it's uncomfortable. J.B. Hunt means these guys here live here and they pick up and deliver here, or they pick up and deliver here, but they're home at night. So they're able to have a much stabler employment base and everybody's happier. So, sometimes innovation is driven by things that we really don't think about, but turn out to be really important.
Yeah, well said. Other questions?
You said something about the cost of per mile or per ton mile doesn't always work out for trains. I mean, it feels like a no-brainer, and that's what the train companies.
Average revenue per ton mile in the United States for railways is about 3 cents. So 3 US cents per ton mile. The average revenue of a truck now is about 12 cents per ton mile. So if you can ship it by rail, of course you do.
I've also seen some ads by, I think it was CSX, about how much more environmentally friendly it is to ship by train. as opposed to shipping by truck.
That's true, that's true. But if I'm a shipper,
I don't care.
what do I care? What I want to know is, well, I mean, and it's the only way the market can operate. You can't really say to a shipper, why don't you pick an inefficient, uneconomic way of shipping because it makes me feel better. That isn't the way the market works. So
But what happens to the railways if a carbon tax is put in?
I think, and have argued, that carbon tax would be good for railways, but not as good as you think. Because even for trucks, the cost of fuel as a percentage of their total operating cost is really not that high. For railroads, even lower. Carbon taxes would hit airlines somewhat, but carbon taxes really won't hit transportation that hard. It's power generation that carbon tax has its major impact on, and industrial uses of energy. The transportation sector is surprisingly less affected by a carbon tax than other sectors of the economy.
I've got one more question that I want to ask.
Then she has one.
Oh, you've got one? I'm sorry, I didn't see. Yeah, please, go ahead.
Just kind of a comment if people are thinking about this, but like one thing that's really sort of slowed down air traffic and made it less appealing is all the security checks and taking off your shoes and everything. And I wonder, if there was an incident on a train, I wonder if all that would start happening on trains as well, all these checks. And
that's a scary question.
yeah.
The TSA has for years indicated that they're not happy with rail security and that they are thinking about doing something, which really terrifies people. If you take the Channel Tunnel from London to Paris, if you take that train, the security to get on that train is airline-like. They actually check people and they verify that they're not carrying things. That's the only one that I know of. But there have been terrorist incidents on trains. There was an incident in the Netherlands some years ago now, in which South Moluccan Indonesian terrorists hijacked a train full of passengers and made them pull them off onto a siding, and then they threatened to kill them unless their friends were released or whatever their demands were. So it's not as if it hasn't happened. But thus far, we've allowed our trains to operate under much lower security levels. And as I said, how many of you would be willing to arrive at an airport much less than an hour before the flight is scheduled to go? Anybody? I wouldn't. Maybe even a little more. But I'll walk into a train station with 10 minutes to go, knowing that I'm going to be fine. So that's 50 minutes. 50 minutes is a major part of a 300-mile trip. It's a big factor. It's not much if you're flying from San Francisco to New York. But if you're flying from San Francisco, or you're taking a train from or flying from San Francisco to LA, it's a big part. It's only an hour and 10-minute trip in the air. So that the airport security and other stuff almost doubles the length of the trip. Now, as I said, that gets evened out on a 3,000-mile trip, but not on a 200-mile trip or 300-mile trip. Conversely, if we ever get to a system of trusted travelers, let's say, whereby if you have a badge, they checked you out, they're sure you're nice and you're not going to cause any problems, and you can walk straight through a gate onto an airplane, it might change the competitive situation fairly significantly. Simple technology, I think. It's just that we're not looking at the problem that way. Actually, there's an even simpler way. Just put more inspectors. Just, put 10 times as many inspectors or 5 times as many inspectors so that they don't have long lines, and more important, you don't have the variability in the line. It isn't even the predicted time. If I knew it was always going to be 10 minutes from the time I get to the line till the time I get through the other side, I can factor that out. But I don't even know that. And I'm obsessive, so well, if it could be 10, but it could be 30, so I better allow 45. Just it's the way people plan. I do.
So if there's no other questions, I've got one final question for you, and then a couple of comments to everybody. So I'm kind of a train fan, always have been.
Me too.
And I'm curious, how do you feel? Is there something we can do in the U.S. to kind of improve the sort of interest in trains that people would have? What would your recommendations be going forward?
Well, you know, when I showed 8 billion Japanese passengers,
Yeah,
okay, they know trains. Everybody in Japan has ridden a train many times. Local trains, high-speed trains, whatever, but they're familiar with trains. Most Americans have never taken a train. I certainly haven't taken them very often. And certainly their experience in many cases is not such as to cause them to do it again. You know? So the first issue in the United States is just to have more good service that people use and are used to, and understand what it is and how to use it and what the barriers and the way the system operates are. And we don't have that. And,
yeah.
and starting from there, the second thing would be, I think, just make it easier to use the train system.
Start from the good business side.
I always look at the question.
Yeah, yeah. So I want to thank everybody for coming to these. One more point to people who've registered for credit. The course evaluations are available online now. Remember, you're evaluating me. You're evaluating the choice of people for the series. You're evaluating whether it was a good set of things that happened. You're not directly evaluating the individual speakers' presentations, only insofar as, you know, we got the right people to do the presenting and we presented the right kind of topics, okay? So I do look forward to reading your comments on that. Look forward to reading your final comments for the last sessions. We wouldn't have these series if it weren't for great audiences. And I really appreciate everybody coming and supporting us by being here. Thanks to everyone, and please join me in thanking Lou. Great.
My address is on the opening slide. You have the slides. I don't mind people sending emails saying, what's the answer to this question? That doesn't bother me at all. So please do. Half the value in these sessions is the follow-up, not the session.
Yeah.
So.
We'll have the slides up in the next few days. Thanks, everybody.
Okay.